go ahead and hit record real quick, and then we can get started. All right. But once again, right before we get started, if you want to follow along, be sure you can download and install Anaconda. That's just a distribution of Python with some useful packages. It's kind of a lot of packages. They're great for data science, but it's a 500 megabyte file. So it might take a little bit to download, so you want to start that now. And this is recorded. It'll be posted on our YouTube. So if you have any questions and you can't follow along right now, feel free to just sit around and watch. And also be good to have Git installed so you can clone our repo. And lastly, our GitHub repo that we're going to be using for some of the notebooks that I'll be showing you is right there. All this should be put in chat. Ray should be getting that right now. But all right, now we're good to go. This is what the download for Anaconda should look like. Make sure it says individual edition because that will make sure that it's the free version. We all like free stuff. So just hit download, follow the installer instructions, and everything should be good. All right, going over the agenda real quick. We have just an overview of the topics. We'll go over some Python basics. I'll take you through what Anaconda is, what Jupyter Notebooks looks like, give you a quick demo on that. And then Sindhu will give you a quick demo on Pandas, Matplotlib, talk about those a bit. And then Ray will take us home with data cleaning and some demo on that. And then we'll take some questions, give you some info for the next info session and all that good stuff. Quick overview of machine learning and data science. Let's take a look at the surface. So machine learning at its most basic high level, I can say is using data to find patterns. So essentially what you want to do is given a bunch of inputs, you want to make a model or algorithm that makes predictions. Now, let's go away from machine learning real quick. Let's say you're going to the store and you want to buy a watermelon. I mean, what's some of the stuff you would look for? You would look for, I don't know, maybe it's tall, maybe it's short, how green is it, does it have yellow spots, brown spots, knock on it a bit, hear a sound it makes. All these intuitions is from experience and past data points that you found from buying watermelon in the past, or just hearing tips on how to, buy a watermelon. Now, this kind of stuff is common. The thing is, what you're doing with machine learning models is essentially all this experience that you would have with, previous purchases that you have in your own life. You're giving it and overloading it with all these data and all these data, and it helps find patterns so it can then make predictions like, is the watermelon good? Now, data science kind of engulfs machine learning. It's a more broad term. I'd say it's compiling raw data into something usable. It kind of is composed of capturing data, make sure that you're capturing it well, so there's not that much noise. Like if you're trying to get someone's age, make sure they can't put in letters, make sure they can't put in negative numbers, make sure there's no typos. Cleaning data, which is anything that slips past the capture, make sure that it's clean so you can set it up for processing and make sure that you have what you need. Because sometimes you'll collect way too much data and you don't need all that. Processing is where machine learning comes in, where you take your data and then you find those patterns, you make those predictions. Visualizing is kind of as it sounds. You'll put it on plots, you'll look at it, and then that'll help you then analyze the data, which is where you'll draw your conclusions. And here's a quote I really like that says, data are just summaries of thousands of stories. Tell a few of those stories to help make the data meaningful. Chip and Dan Heath are both brothers, and they are New York Times bestselling authors. So what this quote means to me personally is that it doesn't matter how much data you have, if you can't make it meaningful, if you can't interpret it, if you can't draw a conclusion, then what's the point? So let's get into Python basics. So Python is great for data science, and there's a lot of great packages for data science. So going back to what I talked about with data science, the data cleaning and analysis, you have NumPy, which is just a mathematical library that's really good with doing matrices and arrays and doing algebra with those. There's Pandas, which actually pretty much uses NumPy as a dependency, but it's more for doing tabular data. You'll do like tables like you would see in Google Sheets or something like that, and it puts all your data plainly in a table. Data visualization is just like what it sounds. You'll have Matplotlib, which is a pretty simple way to plot your data, pretty basic, has a lot of options. And then there's Seaborn, which is a bit more of an aesthetically pleasing package, in my opinion. It's built upon Matplotlib. It has a bit more customization options. And then for data processing, that's the machine learning stuff. Some of you might have heard of TensorFlow. TensorFlow is a kind of low-level machine learning library that lets you build your own algorithms and models. And then scikit-learn is a little bit higher level, a little bit easier to use. You just get to pick some of the more popular models that already exist and plug data into that. Talking about NumPy just a bit more. NumPy stands for numerical Python. Like I said, it's a library used for working with arrays. You know, it can do all sorts of stuff like linear algebra, work with matrices for your transformations. It's actually written in C, and then it was imported to Python. It's really, really fast at what it does. Partly is because all the lists are contiguous in memory. So unlike, you know, something like a vector in like C or C++, where it's like it just points to the next memory location, it's all in a single block of memory. So all the equations and computations are very fast. And Pandas, like I talked about a bit, it just makes data science really good. It's also very high performance. Its data structures are really well. Its main data structure is the data frame, which unlike NumPy is just kind of like a 2D table, which, like I said, looks like a spreadsheet, looks like, you know, sort of like Google Sheets, maybe Excel if you're familiar with that. And it's just tabular. It has rows and columns, and it kind of plainly and cleanly lays everything out. Sorry. Anaconda is a great platform. It's an open source platform for all your needs, data science needs. It's run with Python and R and a lot of different languages. And it's essentially just a collection of a bunch of great data science packages, like some of the ones we went over just now. It also includes some applications like Jupyter Notebooks, which I'm going to get into in a sec, Spider, RStudio, if you're familiar with R, and a lot more. Anaconda is great. Like I said, it's pretty big, around 500 megabytes, I think. I think there is Miniconda if you want to download that. If you're a bit familiar with what you need, you can always like manually include the packages. But Anaconda is a great platform and really convenient to use. Jupyter Notebooks was one of the applications I just went over. It lets you do notes, it lets you do codes, it lets you do visuals. If you ever heard of Google Code Labs, if you ever use MATLAB, it's similar to one of those things. Essentially, it creates documents, and these documents can have code. They can have like text, notes, equations, you name it. So vocab terms I'm going to go over real quick before I jump into the demo is the kernel, which is just the computational engine. The default that we use is Python 3 because we're coding in Python. And cell, which is just a little container. You'll see what it looks like. And it can usually either contain pretty much code, which is self-explanatory, or markdown, which is essentially text. Markdown is a markup language, not unlike HTML, where you kind of just like have syntax that, you know, creates text. So let's get into the demo. To start ourselves off, I'm going to clone the repo real quick. So this link should have already been posted. And I'm going to click the bright green code button right here. So I'm going to copy and paste this link. If you don't have Git installed, you can also download the zip to just get the files. But now that I've done this, I'm going to go to my desktop. I'm going to open my CMD, or essentially my command line. I'm using git bash. I'll zoom in a bit. And I'll just do git clone and then paste the URL there. You can use whatever command line you want. It doesn't really matter. You can also use GitHub Desktop, whatever gets you these files so you can follow along or, you know, do that. So I don't really need this anymore, so I'm just going to exit out. The file's right here. I'm going to open Anaconda, and in the meantime, we'll look through the files, and I'll explain them a bit. Anaconda can take a bit to open, especially with my computer. So let's open the folder real quick. We'll just see some of the files right here. We have some IPYNB files. Ignore the flashing command line popping up over the files. These are just Jupyter Notebook files. If you try to open them with notebooks, it'll know what they're talking about. CSV, or comma-separated value files, is widely used by spreadsheets. And if you open it with like a notepad or something, all it's going to show is like it says values, like strings, integers, whatever, all separated by commas, or really whatever delimiter. It's commas by default, but you can be like, you know, pipes, it can be plus signs, whatever you want. And then you have MD in the README, which is just README and Markdown. So I'll exit out of that. I'm going to launch Jupyter Notebooks whenever my mouse wants to stop loading. And after clicking launch, it won't save for me because I've already opened it, but it might say, you know, what do you want to open this with? You can choose whatever your default browser is. I'm going to go with Google Chrome, and then it should open that real quick. So hopefully it'll open in a second. You see it loading. And then it should open something on localhost. If you notice, since it's localhost, it'll say right here, that means this is just on your personal files. So now I'm on the main page. This is my main root tree. This is actually my users/Tyler folder because my name is Tyler, but it's going to be on whatever your current user folder is. So I'm going to go to desktop. I'm going to find the Diving into Data workshop. And these are the demos that we're going to go over for you right now. But before we do that, all I'm going to do is real quick, I'm going to show you guys how Jupyter works and make sure you know what's happening. So I'm going to select new Python 3. That's our kernel. And this is what a Jupyter Notebook looks like. So let's look at what some of this says. You know, you have your file, you can do a new notebook, open, copy, save as, all the usual stuff. You can download it however you want. You have edit, which lets you cut, copy, paste, delete. You can merge and split cells. I'll explain what that means. You can move cells up and down, find and replace, the normal stuff. View is just some toggle stuff. You can toggle the head bar. I'll keep that on. You can toggle the toolbar. I'll keep that on. And you can toggle the line numbers. I think it's off by default, but I usually turn it on because I like seeing it. You can also insert cells above and below, run your cells, run selected cells, insert. You can do stuff with the kernel. I'll go all of this when it's relevant. So just to start, this is our cell. Whatever is now currently highlighted in blue, and when I click on this, highlighted in green, that's our cell. Right now it's in code, so I'm going to click and turn it to Markdown. So if you're familiar with Markdown, you can do, you know, how you would normally do Markdown. So that's a header. This is a smaller header. I think it would be H2 if you're familiar with HTML. And this is some normal text. You can also insert photos if you go to Edit and then click Insert Image. And if you're familiar with Markdown, you can also just insert how you would normally. So this is how you do it with Markdown. Right here, you put an image address. I'm gonna just steal their logo real quick for the sake of this. And this is Markdown. And then when I'm done, I'm gonna click Run. And now it shows it in Markdown. So these are the notes. So let's say I'm about to write some code. The code below will print hello world. Obviously, you'd probably take a bit better notes when you do it. But right there, I'm just going to do that real quick. And then I'll just type print hello world. And I'm kind of tired of pressing run. So let's look at some of the shortcuts that we can use. Keyboard shortcuts. Let's see some of the ones. Let's see if any of them say run. Check out for it. We can see some of the control ones, control up, whatever. Control enter, run selected cells. All right, so I'll press control enter and it'll give me the output. Instead of clicking plus, I'm tired of that. Let's look for some more keyboard shortcuts. Insert cell below. All right, I'll try that. Let's press B a couple times. Sounds good. Now we have a bunch of new cells. I kind of created a bit too many, so I'm gonna start deleting some. Like I said, you can always click here, delete cells. We can also look for a new keyboard shortcut. The keyboard shortcut is double tapping D. And if you want to delete multiple cells, you can always look at a keyboard shortcut and hold shift and go up and down on the arrow keys. Or you can even just click one, hold shift and click another, and it'll select all of them. I only really want one right now, so let's just delete these and start with the next part. So one important thing about cells in Jupyter is that you don't have to run them synchronously. Like, just because it's in order doesn't mean it has to be run in that order, which can be pretty important if you're doing things like that. Like, let's say we create a variable, x equals 5, and then we create, we want to print that, right? So if I just say, all right, I'm going to print it real quick, it's going to give me an error because x is not defined. The reason it's not defined is because, as you can see here, in the missing in, we never actually ran this. So we never actually set or instantiated x. So if we run that, and then we go back here, it should print 5. Now, this is pretty important if you're doing stuff like, you want to import NumPy at the very beginning of the file, and then you're going to do all your machine learning, all your data stuff, and you try doing something like this. This is just a simple NumPy array. If I try running this, same thing's going to happen. Empty is not defined. I got to run that first and then do that. Something pretty important is, let's say I wanted to just avoid this, and I have these two cells right here. It would probably make sense if these were just in the same block. So I can always do this, edit, and then I could just merge cells, merge cell above. And now they're together, so I won't have that same issue of running them out of order. Real quick, let's reset everything so we can restart with our kernel. That's going to get rid of all the things we run, so it's essentially everything's at 0. It doesn't show it, but if we then try to run this real quick, you can see that's going to give us an error, and then it resets to 1. To make it look a little bit better, we'll do kernel, restart, and clear output. And what that does is everything is going to clear, and nothing will be run, so it'll look just like it is. And then we'll do kernel, restart, and run all. That's going to restart everything, and it will run everything in order that you do it. So 1, 2, 3, 4. That's some of the basics of Jupyter. Like I said, the keyboard shortcuts are going to look great. They're really useful, actually. That's really nice. I don't always love going to the menu and doing everything. There's also tons of help if you want Python, NumPy, SciPy, Matplotlib, Pandas, whatever you name it. And one last thing I don't think I went over is if you double click the markdown, you can re-edit it. And then you can always do Control-Enter and set it back. So I think you guys have the basics down for this. If you have any questions, let us know in chat. We'll get to those. But that's pretty much the basics of Markdown. So I can exit out of there, and then I can leave it to, oh, and I guess one last thing is right here you'll see that I can then shut it down, and the light will go off, and it will show that the live code is no longer running. I'm now going to hand the controls over to Sindhu, who's going to go over Pandas and give you a little bit about data analysis.
Thank you, Taylor. It was great learning about Jupyter Notebook. And just a minute, I am actually like facing some technical issues. Yeah. So I'm going to share my screen now. So why data analysis? So Taylor has explained about different types of NumPy, Pandas, and other stuff in Python. But like, why are we using actually, why are we having a separate library for all this in Python? So actually we have other sources like Excel in order to have, take the data and analyze that data, get the output of that data. Let's say like I have this Excel sheet. This contains the New York City weather for 31 days, and it has different aspects like temperature, visibility of the wind speed, and temperature, and the events like rain or which days it was raining or snowing, etc. And this data is kind of like not so clean, and it has some empty values as well. If I want to find what is the maximum temperature that has been there in these particular 30 days, or what is in which days was it raining, or what is the average wind speed. So how do I find it? I mean, we have like many, Excel is very powerful tool, and we can immediately get filtered these events with respect to rain and get the data. But sometimes the data will be so huge with billions of rows that it is not always possible to put the data in Excel, or it might be taking a lot of time as well to get the output of that particular data. So in order to forego or achieve that kind of faster output, we actually can use programming language, because like I know Python or Java, and I can write a couple of lines of code in that particular programming language and come up with a solution for that. But so let me launch my Jupyter Notebook. It's taking some time. Um, So I have just written a Python code for getting these three: the maximum temperature, and the days it was raining, and the average wind speed. So my laptop just went through an upgrade. Yeah, let me go to that folder, and so so this is the program I have written in Python to get the three parameter values. So let me run this code. As Taylor said, if you give control and enter, that cell will be executed. And these are the outputs for these three parameters. But this code is actually 72 lines. And is it really required to write that much amount of uh, programming for just these three simple statistical calculations? Won't it take like I mean like it'll that is where actually pandas or numpy comes into picture. It is very fast and it returns it the computations are very fast and the output time is very less, and it gives the output in a very few lines of code. So it actually these three can be given in just 3 lines of code with pandas, and that is where uh, it is mainly useful. So in order to import pandas, we have to use this command import pandas, and PD is a small abbreviation for using pandas. Uh, so Taylor has mentioned about data frame in pandas. So if you see here, there are different ways of creating a data frame. So we can use the input as a CSV file, comma separated file, or an Excel sheet, or a Python dictionary. I mean, we can store the values in the form of a Python dictionary and send it in the read that particular thing into the data frame, or convert a list of tuples into the data frame, or use a list of dictionaries. So in this demo, I'll be going through some of the basic functions so that when data cleaning is done by Raymond, he can further explain about these functions and where we'll be using these. So if we go back to the Jupyter Notebook, let me initialize and read the CSV. So actually the star in this particular in says that it is still running. Yeah, so now the data frame is displayed, and all the the CSV attributes are converted towards the rows and columns in this particular data frame and displayed. And as I said, there are some empty values in this particular CSV file, and it was here, and like many values are there which are like empty. So these are actually given as NaN, not a number, and written in this particular data frame. So this pandas has a function called as max, and if you give that particular column name and call this max function, it will give the output. And let me execute this part. So we get the maximum temperature is 50 for those 30 days in the New York City. uh, Instead of using 72 lines of code, we can just give this one particular line and get the output. Same way, we can use this command where the events are equal to rain and return the values of the EST, that is the date of this particular data frame. So let me run. And if you have installed Anaconda in your system, you can also start parallelly working and check these aspects out in your local machine. And uh, coming to the average, Pandas has a function called as mean, which will return the average of that particular column. So wind speed MPH is a column name, and we are getting the mean of that, and it is 6.89. Let me cross check if that is the value which I was getting previously. So I see that here it is 6.22, and that we are getting a different value here. That might be because there are some NaN values in this particular wind speed MPH, and they are not considered into the output of this particular value. So in order to have a legitimate value or authenticate value, we have to convert or clean the data and properly then execute our commands. So I am just filling these particular rows or cells with 0. and we use fill any method for that. So let me run this. So it actually fills the NaN values with 0 in this particular data frame. So now when we run the same method again, now the value is 6.22, which is kind of expected when we had the before programming code. Some other a couple of methods which we use frequently are head. Head is like the seeing this entire data frame is kind of messy. If you want to just check or use like what kind of format is this EST or temperature, or just to check the outputs, how it is going, how it is working, how it is being seen. So we just have, if you give head, it just returns the first 5 rows of that particular data frame, and it can take optional arguments, and the argument can be the number of rows you want to see in this particular data frame. If you want to see 20, then we can give 20, and that will return the top 20 rows of the data frame. And tail actually gives the last 5 rows, same as head, but it comes from the last. So you can try these commands in this Jupyter notebook once you download. So shape is one more method, and it actually gives the rows and columns of this data frame. Instead of counting or parsing entire data, this actually is a built-in command, and it has a complexity of 1. And drop is a method which is used to drop that particular column. We have to give the argument as column name and 1. Only this particular column, or we can give multiple column names also to drop those particular columns. And I'm just giving head to display only the top 5 values of the rows. So, and there is an alternate way. The previously I was giving the column name in parenthesis in order to get the mean or sum or any other methods on this particular column. There is one more way to give the same method, use the same method, that is giving the column name after the instead of parenthesis, we'll just give df dot the column name dot whatever method you want to call in. So this also gives the same way, same answer as before. And there are a couple of other functions like minimum sum to give the minimum value of that particular column, or sum of or aggregate of all the elements in that particular column. So describe is like it gives a overall statistics of that particular data frame, or if you want for a single column also we can use describe, and it actually gives so many important outputs like count, average, standard deviation, minimum, maximum, and percentiles of all the columns. So this is actually really, I mean, instead of looking at the whole Excel sheet or the data frame, this actually gives very useful information on how many rows are there in each of the columns, and what is the average temperature in all the days, or what is the how humid is New York City, or in general, or what is the maximum value of the wind, so that people can take care when it is windy, or something of that sort. Some kind of information we can get uh, by using this describe method. So once we are done with all these changes and we want to store it in a new file, then we can use this to CSV function and give the argument as the file name you want to save in. So when I run this command, a new file will be created in the same path. Actually, the input can be uh, this, it can be file name, or it can be the aggregate path or the relative path. Anything is, it can take anything, all of the three. And so if we see the new file, it has the changed values. You can see like zeros are there. These are the changed values. And some things we can see here like 0, 1, 2, 3, 4, and these are kind of unnecessary if you I mean, these don't have any value in this particular list. So we can just remove them by using an optional parameter called index and set it to false, so that the index is removed. So if we go back and open the file again, so those things are removed here. And sometimes we want to pass the data without the header as well. I mean, just go through the data and pass it, and because this data will be passing for some other statistics also. So in that case, if I don't require EST, these column names, I can just set the header as false, and that will be removed. So let me run this, and if we open a new file, the columns are actually removed here. So this is actually like a very introductory session about pandas, and there is a lot of methods and interesting things in pandas which we can learn a lot. So there are a couple of methods here, and this cheat sheet, I have included some links, and we'll include it in the after the session also, so that you can dig further and learn more about it. So we have learned about pandas. And coming to the data visualization, there are a lot of data visualization libraries in Python, but like, why a data visualization is necessary? Can't we know, like, I just said, like, in the charts we have so much of data and it is like really useful, but human eye is actually very attracted towards charts and colors, and they actually can gain even more input and analyze the data even more faster if we use charts or graphs. And that is the reason why data visualization is important. And so Python offers different libraries, and each has its own importance. Like Taylor said, explained about matplotlib and seaborn. I'll be going through a couple of other libraries as well. So seaborn is actually aesthetically pleasing and modern, and it is built on matplotlib. So and ggplot is actually taken from R, and bokeh is native towards Python. And it'll, if you want to have real-time streaming data, something like stocks, or which have some change of data in the real time, we can use bokeh. And geoplotlib is actually for creating maps and geographical data. And this is a um, flowchart which actually describes it in an easier way. So matplotlib is used when we have our own data and own outputs we want to show. Then if you want to create a unique plot, then use matplotlib. If you want to create a quick plot, I mean something you want to see for yourself, what is happening when you're writing code for pandas, then we can use pandas. Also gives plot functionality, and we can use that. And seaborn is for it has box charts, something like interactive. I mean, you can click on the graphs and get the answers for when using seaborn. So in this particular workshop, we'll be covering only matplotlib, since it is the introductory workshop. And these are the some of the graphs which I'll be covering today. Line plot, each has its own importance. So I'll be covering today about pie chart, histogram, bar graph, and line plot. So let me open the Jupyter Notebook. There is something called as matplotlib demo. You can also parallelly open that. So first, for every time we need to, before using these functionalities or libraries, we have to import the pyplot from matplotlib in order to plot the graphs. And I'm using this matplotlib inline function. This is also called as a magic function if you have this percentage symbol before. That is because if you want to save the graphs which are generated in this particular notebook, we need to use this matplotlib inline function. So once we run this, so it's still executing. Yeah, it got executed. So coming to the line graphs, I'll just give a brief introduction on how to create each graphs. So line graph has a set of values. We are giving x 7 values and y as 7 more values. And if you just give plot and xy, then line graph. So first I didn't initialize the x and y variables. So let me run that again. And so when I run the plot function in pyplot, a line graph is drawn uh, with respect to the x and y axis. But if you see this graph, I do not know what the x-axis is, or what the y-axis is, or what actually the graph represents. So we have to have the label of the x-axis, y-axis, and the title. For those, we'll be using the x label, y label, title of the pyplot, and give the names which we want to give for the labels. So if I, and G plus, this is an optional attribute. Without that also it will work, and it will take the default as blue. But if I want the color as green, then I can just give G plus. If I want to have a line plot, then I can give as line, and a solid line is drawn across all the plotting points. So there are a couple of options. If I want a line and dotted line, then I can give this input, and a line dotted line is line dot plot is drawn. So we can actually explore more with this. G is for green, R is for red, Y is for yellow, that kind of things we can. And so instead of this, I'm using plus as here as marker, and I can use star also. So it'll give these marker. We can change these as well. And this is one way of plotting the graph, and this is another way of plotting the graph by giving the color as blue, marker as plus. It actually gives the same output for both. So since I have given blue color, the line graph is in blue. And there are like so many optional parameters in pyplot. One is marker size. This marker size also we can increase, so that we can or decrease, depends on our particular parameters or which we want to show. If I change it to 20, then the markers will be less smaller in size. And alpha is a one more attribute in pyplot, and it is actually the transparency of the markers or the graph, and it has a scale of 0 to 1. If it is 0, it is totally transparent. If it is 1, it is totally opaque. So if I put 0.5 and run, it is semi-transparent. So based on whatever our particular choice, we can change this. This is actually really helpful if we have multiple graphs plotting on one another, and we want to not to have the graph so messy. We can use the alpha value. So I was talking about multiple plots in the same graph. How do you do that? So I just took some of the parameters as in the maximum temperature, minimum temperature, average temperature, and the days of the New York City. And once I initialize this, we can plot all the graphs in one particular graph using the same command as before. But if you see this graph, I do not know what orange corresponds to, or green corresponds to, or blue corresponds to. So for this, we'll have to have a legend, or like blue corresponds to the maximum, or green corresponds to the minimum. So for that, we'll be using the legend functionality in pyplot. Yeah, and these are like couple of things which we have already used before: X label, Y label, title, uh, and if you use the legend will be here. Best log best is an optional parameter. That is, it'll the pyplot itself takes the best place to keep the legend and places it there. And there are some optional parameters in legend also, like shadow, font size, where to place the legend on the upper right or upper left or lower right, that kind of thing. Or if you want to increase the font size, we can see like this is more than this and there is a shadow here. Um, so that concludes the line graph and multiple graphs. And coming to the subplots, this will be further discussed by Ray. But to how you here all three graphs are in the same graph, and I want to have two different graphs showing two different plots. For that, we'll be using subplot functionality, and subplots it can take the number of graphs you want to take, and it can also take stacked graphs. Like if you give 2 comma 2, then 2 rows and 2 columns will be created, and 4 graphs will be displayed. For example, I'm taking 2 here and generating a subplot. So we can see 2 graphs are created here, and I have given the x label and y label for the second graph. You can try for the first graph. um, that concludes the line graph in pyplot. So coming to the bar graph, let us say we have 4 technology companies, and we have some revenues of those technology companies. We want to plot the bar chart for these values. So Python, let me initialize this. And Python gives a functionality called as bar, which will uh, plot the graphs with respect to the x-axis, and these points are actually these points based on the length of the x-axis, x parameters. It will take the x positions and store it in an array, and then that will be giving us the x-axis inputs, and the revenue is considered as the y-axis, and the label of the graph is revenue. So if you run this, we actually get a bar graph uh, with y label and the title. I actually didn't give X label. Maybe like you can try how to give X label for yourself. So, and we can actually plot multiple graphs using bar graph. So profit is one more array. I have created one more array called profit, which is having profit for all the 4 companies in billions. So let me initialize this and plot the bar chart. So here, if you see, orange corresponds to profit, and blue corresponds to revenue, and Amazon is the company which is which is having the most revenue, while very less profit. But Google is having more profit among all the so these kind of inferences we can take from this particular graph very easily. And if you don't have and legend comes in handy to know like which is what exactly. I mean, blue corresponds to what, or orange corresponds to what. And sometimes if you want to plot horizontally, actually rather than seeing like this, if you have a horizontal graph, it is easy for us to see which is more. So bar h is a method in pyplot which is used to plot the horizontal bar graphs. Uh, so there is one more graph called as histogram. Um, where we want to consider like what kind of groups we want to divide into. Let's say like we have an array of blood sugar for different people, and we want to group data. How many people are below 80, or how many people are below 80, 110 and 80. That kind of inferences we can get from histogram. And by default, the number of bins is set to 0, and we can actually change this bin size. Bin size is nothing but plotting the number of these blue blocks. So we can actually have the bin size as variable, and it will decrease the uh, data for each of the uh, groups. And coming to the pie chart, when we want output in terms of percentage to see which is having the more expense, or which is having a very less expense, or where we can save, I took some of the values for a household expense, and these are the expenses for each of these values. So pi is the method in PyPlot which is used for plotting the pie chart, and labels is for I'll just so if we don't have this labels is an optional parameter, and we just plot the graph, then it is like this. We do not know what is what, so in order to have a label, we'll just give uh, labels as the input as the this array which has the expenses for the names of each of the expense. So if we run this, we have the pie chart with home rent, food, phone bill with different colors, but it is still not clear on what the percentage is exactly. We know like home rent is the major expense, or the car or bill is even less than car, but still we need to know what is exactly what. So for that we'll use auto piece percentage, which will give the percentage of each of the wedges. And shadow is one more functionality in PyPlot, which will set the shadow of this PyPlot as true. So as you can see here, the shadow is set, and to get the percentages, here the percentages are displayed, and if you want to decrease or increase the radius of this particular pie chart, then we can reduce or increase the let's say I give it as 3, then it will be very big. So based on however we want, we can decrease or increase these particular parameters. And so axis of equal actually specifies that the x and y should be same when you are plotting a circle. This is for aesthetic importance, because if it is symmetrical, the human eye is more inclined towards, it seems. So apart from that, we have other optional parameters like explode or counterclock or starting at an angle. So let me run this, maybe I can explain it. So explode is like how much far you want the wedges to be away from the center. So that is the, if you want to highlight one particular wedge, then this particular argument is really helpful. And counterclockwise is how the wedges are organized with each other. So as you can see, this is uh, so as we go towards the counterclockwise, it keeps on increasing, and the start angle is 45 degrees, because the first array, which is the home rent, is the is in 45 degrees angle with the x-axis. So so once we have done all these changes, we can save this pie chart to a PDF, and not only this pie chart, we can use this command for any of the graphs which we want to save. So we can use save figure, which is provided by PyPlot, and give the input as the name of the output file we want to give, And these are some of the optional parameters. This tight is, it will not save any other area. It will just save the area where the plot is. And pad inches is the tight bound of this particular plot plus the number of inches which you want to pad for this particular figure. So when we run this, it is a new file will be created called as piechart.pdf, and the pie chart is displayed in the PDF, and we can use this pie chart elsewhere also. So we can try with different values, and we can actually see the difference. I'll show for one as pad inches as 2, and the chart is actually, I mean, the space is actually smaller, the padding space. So this concludes the graphs, and I'm just giving scatter plot as an example. You can try changing these particular values, alpha as 7, 0.7, or increasing the area of the circles, and see how it changes for yourself. So with this, I'm uh, I'm giving the control towards Raymond, and he'll explain you about the NFL demo. Thank you.
Thank you, Sindhu. So overall, Tyler and Sindhu have gone over very good tools such as Anaconda, Pandas, NumPy that are very essential for one seeking to pursue a path in data science. And then now that you have gotten introduced to some of those tools, I would like to just go over what data cleaning is and how it pertains to data science. So why clean data? Data is the lifeblood of data science and machine learning, and it can reveal trends that allow a company, an individual, or researcher to find an advantage in whatever market they're working in. As such, quality and descriptive data is very important. The amount of data that is gathered around the world continues to exponentially increase every year, and as such, data sets themselves are becoming extremely large and more descriptive. This makes it very important to confirm that the data is carefully processed and appraised before starting whatever analysis you so choose to pursue. Often, a simple model that uses a dataset that is high quality and standardized can beat a complex and powerful model that uses a flawed dataset. In addition, datasets in real life are often messy and they contain numerous issues that come from both automation or human error. And these usually show up in like the acquisition process. These issues need to be handled before continuing with whatever you desire to perform on such a data set. If you choose to not clean up your data and attempt to make a conclusion with said dirty data, you will arrive at a false or misleading conclusion. This can lead to costly consequences, and that makes it very essential that you make sure to clean your data. And a useful mnemonic is garbage in, garbage out. So some of the common data issues I talked about in messy data sets are missing, duplicate, or values irrelevant to whatever problem you're trying to solve. In addition, some entries can be inconsistent. As pictured here, 2 ways to write the United Kingdom is UK, the abbreviation, or United Kingdom spelled out. In addition, data values such as phone numbers, where something can have the area code, some phone numbers cannot have the area code. Others include like international numbers, some surround the area codes with parentheses, and etc. Dates, some having month, year, a month, day, year format, or day, month, year format, with slashes or with dashes, or spelling it out. And then time, AM, PM, military time, and etc. Entries can also just have typos or simple errors. One very hard spot error is white space errors. So it is important that when you're trying to go through your data set, you keep an eye out for simple white space errors, as they can turn 2 identical values to have different meanings. Sadly, there are other errors not listed, and this is why data cleaning is considered not as glamorous as other aspects of data science. However, it is still extremely important. All in all, you want to make sure that your dataset follows a standard and account for whatever mistakes and inconsistencies you may encounter. So first, I'm going to talk about how one may handle missing values. Visualize here is a typical process that occurs when you handle missing values in your data. Initially, you assess how much of your data is missing or invalid and just do like a preliminary scan. From this point, you have two options that you can choose. First, you can drop data entries that don't satisfy the necessary constraints you want, or just drop the columns that have no entries. This option is better if you are pressed for time or do not feel like the entries or columns that have no values provide enough marginal benefit to maintain. Alternatively, you can use imputation. This term means that you will replace the missing data with substituted values. Some examples were shown earlier in Sindhu's demo when she just replaced NaN values with 0. But you can also choose to replace it with the mean of all the values for that specific attribute or the next non-null value in the column. Particularly for the next non-null value, it would usually work if the data set is ordered. But whenever you try to use imputation, you have to be careful with whatever option you may choose because you have to make sure that it makes sense and you're not trying to jump towards another conclusion. Otherwise, you'll lead to a false conclusion with your own analysis. Another technique in dealing with data is to scale or normalize it. So for scaling normalization, these two methods help transform the values that you need into more helpful properties. An important distinction is that scaling changes the range of the data and normalization changes the distribution shape. So for scaling, since it involves transforming data to follow a specific scale, it's very useful when you're using a model that has, let's say, differences in one that mean vastly different things. So for example, a change of dollar in like a change of dollar is very different from a change of 1 Japanese yen. And this cannot be this may be less likely to be picked up by whatever analysis or model you're using. And scaling can help solve this issue and change the data sets to have a more similar range. As for normalization, you're basically transforming your data to fit a more normal distribution or Gaussian distribution. Usually you will normalize your data whenever you aim to use a machine learning or statistics technique that assumes that your data is normally distributed. This is actually very common and it shows up in things like linear discriminant analysis, other models, and etc. So pictured here are some visual representations of scaling and normalization. The plots here are distribution plots, and the x-axis just shows the observed values, and then the y-axis shows the proportion of the values within that observation. As you can see, scaling changed the range of the observation. It went from 0 to 8 to 0 to 1, but it didn't change the shape of the distribution overall. On the other hand, normalization, you can see it changed from skewed right to more of a bell-shaped curve. And this obviously changes the distribution shape. And lastly, another method to clean your data is to account for inconsistent entries. So when you're trying to do with inconsistent entries, like with all different issues with data, you want to do a preliminary scan of the values, particularly in whatever column in data set you're looking at. So if you're working with like a finite set, like countries or cities, you can just find all the unique entries and see that they're all just unique. So there's not like a capital South Korea and then just a lowercase South Korea. But if your values are infinite and have a pattern though, you would likely get too many entries if you just look for unique values like dates. So for this, you would have to see if they match a regular expression or pattern. No, so after scanning your data, if you find inconsistent entries, you must make a choice on how you want to standardize your data set. This is up to you, but it should be intuitive and apply to all the values in whatever column you are working with. Once you make this standardization choice, now you can fix the data. So usually you can apply this technique called fuzzy matching to reduce the inconsistent values. Fuzzy matching is a technique that helps you identify non-target matches that are similar to a target match and make the needed transformation. These non-target matches must fulfill a certain threshold of similarity with the target match before you are allowed to transform them into the target value. And this is shown right here in this visualization. So basically, each of these data values has like small issues. This one includes white space errors. This one uses the abbreviation. This is just a normal way of representing it. This one has it as lowercase, and then this one uses hyphen as the separator. But if I were to do fuzzy matching, I would set this as a target value. And then these values would cross a certain threshold of similarity. And then as such, the algorithm would transform them into the target value. And now your model, whatever analysis you're doing, will treat all these values with the same meaning. So now that I've described some of the methods for data cleaning, it's time to show you guys how one may do it in Jupyter Notebooks. So here's the notebook. Basically, I'll go over how to handle missing faulty entries and apply scaling or normalization. So here I imported Pandas and NumPy, which were described earlier, and then I also read the CSV file. If anybody's looking at the repo, notice that I didn't include it in just say the GitHub repo because it was too large of a data set. However, the README includes instructions on how to obtain it from Kaggle. So over the course of data science, you may encounter that like you might not know what a function is, or you have to like do some more research. Well, let's say if you want to know what read CSV does, what you would do is you go to help, and then you know that's a pandas function. So you go to the pandas reference, and then you just search the docs, and then you find read CSV. And now you found the documentation for the function. As you can see, there's a lot of different parameters you can choose and a description of basically what it does. And then you can just dive right in and figure out more about it. But currently I'm going to import the data set and try to see how we can handle the missing data. So yeah, the data set is pretty large, but all right, it's loaded. So now I'm using the head function that was described earlier. It just basically gives you a glimpse at the first 5 rows. And as you can see, there are 102 columns, but Jupyter Notebooks doesn't want to display all that, so they just use the ellipses. To count all the missing values, I used the isNull function to see how much of the data values or the cells in the data frame are empty, and then add them all together. And then after that, I decided to only splice the first 10 columns because I don't want to look at every single column. So here you can observe that some attributes have a lot of empty values and others have like none. Sometimes when you're looking at this data, you can make like guesses to why certain values have tons of, what's it called, no values. If this is the play-by-play data set, then maybe if downs has a ton of no values, maybe some plays just didn't have downs, or it's like a penalty or something. You would have to do more research on the documentation and the description of the data set to figure out why this may have happened. But if you want to just calculate how much of the data set is missing, you can also just do a simple percentage calculation. So what I did is that I got the shape value. This was described earlier. It returns a tuple that has the number of rows and the number of columns. And then I use the NumPy product method, it just multiplies rows by columns, so you get total cells. And then using the value I calculated earlier, I just added them all together to get the number of missing values, then did a percentage calculation, and then figured out the number of missing data. So now that we know how much data is missing, let's go over one of the 2 options to handle this missing data. So first of all, if you are pressed in time or you don't feel like dealing with any entry with no values, you can just drop everything. However, if you drop every entry with a null value, you get no data, because sometimes when people are collecting data, not every entry is going to have an attribute for every single column, and there is 102 columns, so it may not be applicable to just have every single attribute filled. So from this point, you have to make a decision on what's your threshold, or what type of choice you make when you drop data. And for this case, use the drop NA function to drop columns that have at least one missing value. And then the axis one just defines the orientation. It just means you're dropping columns. And then you just get the head. So now if we get rid of all the columns with no entries, now that you see that every single row has data now, or entry. And although it may say none, these are actually strings. So yeah, before you guys get confused. And then now you can observe that the data set now has 41 columns. So a lot of columns were actually dropped. And if we print out the shape for the original data and then the data without the no columns, you can see that we lost like around 60 columns. And this can be very bad if you want to like make a conclusion with your model or data set, as losing 60% is a significant chunk of information. And you have to further analyze if you really need these 60 columns, and see what to move on from there. And on the other hand, you can use imputation or substitution. And in this case, I use the log method to just get all the rows, but only get a certain amount of columns from EPA to season, and then just get the head for it. So with this subset, I obtained these values. As you can see, there's some null values in here, and these 6 and then these 6. But the typical way of easy imputation is just to fill them all with 0. So once you fill them all with 0, you see that they all contain 0 values now. And now your whatever analysis or model you choose to use, you won't run into any like issues with inputting no values, and you can perform whatever thing you need to do. So after handling and missing data, now we can move on to scaling and normalization. So here I imported the necessary libraries that I used to show scaling normalization. Stats module from SciPy, Seaborn, which we described earlier when we were talking about plotting, the matplotlib pyplot, and I set the np random seed for demonstrative purposes so that every single, let's say, run is the same. So yeah, just import all these. And then first, I'm going to show scaling. So what I chose to do is I chose to randomly generate an exponential distribution with 1,000 data points, and then use the NumPy interpolate function to scale the data to fit a new range of 0 and 1. I would map the min and the max to 0 and 1, and then transform it into the scaled data. Then I decided to plot both subplots into one graph, and then one showing the original data and one with the scaled data. So here you can see it actually matches up with the slides, and the original range is 0 to 8, and then the new range is 0 to 1. And it just shows how we effectively change the range of the data. And over here in normalization, I use the boxcox method from the stats module from SciPy in order to transform the original data into normalized data. And boxcox basically uses a statistical technique to just transform the data into a more normal curve. You guys can do more research on it later. For the purposes of this workshop, I won't delve too deep into the theory. But after we normalize, I decided to follow plotting in the same structure to the one above, and then just plot the original data alongside the normalized data. And as you can see, it also matches up with the slides as well. And there's the right skewed and then a more normal curve. So yeah, this concludes the data cleaning portion of the, what's it called, demonstration. And now we will go back to the slides. So yeah, this concludes our workshop. And as for the next workshop, it will be more about models for machine learning and problem framing for machine learning. We still haven't decided the date, but make sure to join our socials and follow our DSC chapter page to get more updates on the next meeting. And if you have any questions, just feel free to type in the chat. Thank you, everyone.